chosen to talk about urbanization. So why did I choose this? It is because it's a common phenomenon in Africa. We are converting a lot of lands for settlement. Urban areas are being expanded to either other ecosystem areas. And also today, I thought to go through. So I have chosen a case of Ngongoa city. It's in the peripheries of Yaoundé. I've chosen this because I had the promise from my guy there, so who had to attend the training, but maybe didn't make it. So, but the approach is this one. In our notebook, uh, we can in our sandbox we can log in and try to import functions as we do, and from our data cube we can do everything, but also try to specify what the package is using. Application will be urbanization from our data cube, and of course we'll be able to specify the location of the area we'll be working from. So now we entered the coordinates of this area, so the latitude of the longitude of the area, and also try to put a buffer. So it means that the upper boundary, the lower boundary, the eastern and the western boundaries for our center coordinates. And after, we can also choose the timeline. Here we want to assess the change between 2017 and 2020. And we can try to view our location. It should be this in this red square, and this location, it is as you see, if you see Yaoundé on the eastern, the left side, you could see this is an area in the peripherals of Yaoundé, and that to that area, the urban is being expanded. And from here, we can also try to choose our bands we'll be using, and try also to load the geomedian for our Sentinel-2 annual, and then the query. Of course, try to display all our geomedians and specify the parameters as they are. And now we can display the RGB, that's red, green, blue images. Those are two color images, and for one for 2017 and the other for 2020. And now we are going to use this called enhanced normalized difference in previous service index. And this index was developed by this
The screen is not moving, please, Mr. Boma. We can't see anything you're saying. Are you just explaining in theory?
You can see my screen?
We can see your screen, but we can't see it moving. Are you talking in theory right now?
It's moving. It's moving actually. It's moving?
No.
No?
No, Joseph, it's not scrolling down.
Let me stop and share. So yeah,
Okay.
It's amazing. Actually, I've been. This is my screen. You can see it? Now it's
yes. Yeah, now it's scrolling down.
Is it moving?
Yes. Yes, it's moving.
Oh.
Yes, it's moving. It's moving now.
So amazing. Actually, I said we'll be working from this Ngongoa city. It is, if you see, this is Yaoundé. This is the peripheral, the eastern peripherals of Yaoundé. To this area, the urban is expanding. And also we'll be specifying our parameters, the time and the band to be able to calculate our index and also try to specify which image that geomed sentinel annual. And also, if we learn our geomedians, we display this RGB mid true color imagery, one for 2017, other for 2020. So now we're going to use the enhanced normal difference in previous surfaces index, and this is a way of calculating the urban sprawl, and it is using um, this band as they are calculated here. And if we run it, we'll be getting this and DC, one for the year 2017, the other for the year 2020. Now you can have an idea, a visual idea of how this urbanization has been expanding or declining in some areas of Kongoa. But this is hard to interpret, and also it could show us the behavior of our indices, but you can also calculate the urban extent and try to fix the thresholds and run. So those are the extent in 2017, this is the extent in 2020. Still, it is still a visual interpretation. Someone could say how much changed from urbanization to non-urbanization and how it looks like. So that's why down here we can try to plot on the area, and you could see from this diagram that the Kongoa city shifted from 3.33 something to 4.39 something. So it's almost increased by 30% between 2017 and 2020. It means that the urban growth, the urban sprawl in that area is that high. And also we can check what changed to what. In red dot, there have been urban growth. In the blue dot, there have been urban decline. And of course, in the gray, it has been remaining urban. What that means, so you can see the upper corner, when they check, they saw maybe it's becoming a deforested area, while other parts in the central part and the southern part, southeastern part of the area are being built on a high speed, if I can say, from 2017 until nowadays. So what that means, this was an example for Yaoundé, Kongoa, but also we have several examples for other time. So this notebook, I didn't do much time. It is free available on the Africa Sandbox. You can log in and check. It's a matter of changing. So it's a matter of changing this XY coordinates to specify your own location, your location of your target, and also try to specify the buffer you need, that you can run the code and have an idea, even quantify the urban growth or the settlement growth in a given area. So you are the most welcome for other comments or questions. Thank you.
Thank you, Joseph, for taking us through the urban change detection notebooks. Please, is there any question you have or comment you have based on what Joseph just showed us from the sandbox? If you have any question for Joseph, You can.
I have a question.
Okay. Please.
Can I continue?
Yes, please go on.
Yes, I want to know if you say urban decline, what specifically are you looking at? Is it the built area
So,
or because sometimes maybe you can have the same reflection from built area and open area. So I don't know what is the decline in terms of your
so,
classification.
so actually, I've been asked the same question by one guy from GIZ. So what you call urban decline, maybe first of all, the area had some buildings and the people moved to other developed localities. You may be to access to infrastructure and so on, but also it should be maybe at this the upper part. Could you see my cursor? The upper right part of Mungoa. When I checked, maybe the image was taken during a dry season, and the area was seems like reflecting the same or bare soil. And after the other one was not that dry and it was reflecting like a Leo forest. So it should be some issue of accuracy, but also it should be some issues of location of buildings sometimes. Did I answer your question, please?
Yeah, no, it's fine. It's okay. You answered it well. That's what I discovered because we did the same for Gaborone also. So I was
Yeah.
wondering, yes, like you say, in some places, maybe it was because there was flooding and then it appeared as if as a reflection of some sort when the image was taken, like a water reflection. And then at some point it was dry and then it showed as if it's built area. So as a combination of the dryness and the flooding in the town, because sometimes in towns you get flooding also, like a storm drainage flooding, flash floods.
Yes, I agree with you. Actually, that's why there's always need for field validation. Actually, my friend Charlie from Yaoundé didn't attend. He's even the one proposing the area. Unfortunately, he didn't attend. But I think always there might be some kind of um, uh, false what some errors causing confusing some areas depending upon the seasons or behavior. So I agree with you.
Thank you, Joseph,
You're
for
welcome.
the, thank you. And thank you, Dr. Kalabili, also for the question in relation to the decline and how the explanation went. That was very great. Thank you, Joseph.
You're welcome.
Okay, so from this end, I will share my screen. Please, can you see my screen? Hello?
Yes, I can
Yes,
see
we
your
see
screen.
it.
Okay, thank you.
Welcome.
Okay, so there is a new notebook that has actually been developed, which is called the Wetland Insight Tool. Hello, please, can you hear me? Joseph, can you hear me?
Yes, please.
Okay, so the Wetland Insight Tool is a new notebook that has been developed. If you log on to your sandbox and you move into the real world folder, at the last part, you are going to see the wetland inside to notebook, which has actually been added to the new notebook. One thing that makes this wetland inside to actually user friendly with less code is it's interactive, meaning you get the chance to move around the map and choose an area of interest that you want to work with. So the first thing that you have to do is when you open the wetland map notebook in the real world folder, we give you a detailed explanation of what the tool is all about and what wetland is also all about. And what you see here is an example of the end result after you've actually run the notebook. And the process that it actually goes through to be able to develop this result for you is what is also shown on the far right side. That's the classification logic that the wetland tool actually is based on to develop. Then from here, the next thing is actually the description about the wetlands to how you'll be able to run the wetland tool. So from the first thing is to set your parameters for the wetland area inside. Then you draw the polygon using the interactive Jupyter widget, which we will talk about it. Then after that, you click on the run. So this is just how the tool actually works. Following these three procedures, you'll be able to run the tool. So you give an additional instruction for it so that you won't actually feel confused with it. And these are the analysis parameters. So the parameters that you have to set are these ones. And once you move to the widget, you'll be able to see it. So with this one, the only thing that you need to run is this particular cell. If you come to kernel, restart kernel and run all cell, it will just run only this cell for you. And once this cell is run, you'll be able to have the toolkit, that's the wetland inside toolkit, actually showing on the screen for you. So what you see here is the toolkit area. At this far, the first one is the DE Africa overlay. So these are parameters from the Digital Earth Africa services. So you have the Sentinel-2 and you have the water observation. So based on the base map that you want to use, you can choose any of these. You can go with the water observation for instance, because it actually helps you to identify areas where you have water bodies and wetlands areas also. Then you specify the start date and the end date. For this demonstration, you're going to use the start date of January 1st, 2019. So you can actually type, or you can click on the file right of the calendar to actually drop down the calendar for you. Then the ending period, we are going to look in 30th June 2019. So this is what you want to do. Then you also talk about the imagery, the image quality that you want to use. So you're going to go for 0.5. It actually ranges from 0 to 1. So any value between, depending on the mean good data that you are after. If with this one, you want 50% of cloud-free images. So that's why I'll specify 0.1. If you want 90%, it's actually going to be 0.9. Then we have the rate sampling frequency, the output CSV, and the output plot. The rate sampling frequency is actually the rate sampling how you would like to. Probably you would prefer a quarter or you prefer yearly. But because this one you are just using 6 months time period, I used 1 month rate sampling period. So you're going to get the 1 month recycling period. After inputting this parameter, if you have a name for how you want the output to become, you can change the example and give it that particular name you want to use. And the plot also, if you want to export it out also, you change the name and give it the plot. So after specifying these parameters, The next thing is to actually go onto the map and select the area of interest that you want to work with. So let me zoom in here using the map. So I'll zoom in here and I'll come to a small portion of Lake Chad. So once I'm there, once I zoom into the area of interest that I want to work with, the next thing is to draw my polygon. So it's either I go to the polygon or I can even use the square polygon, depending on the one that I want to use. So let me use the polygon, this one, whereby I can give any amount of shape that I would like to use. So right now I've been able to draw the polygon around the area of interest that I want to work with. After selecting the area of interest, the next thing is to click on the run button. So once you click on the run button, it's going to actually compute, compute the area, the wetland inside to for that particular area for you and give us the results beneath here. Because actually there's a lot of data, it will actually take some time. But whilst it's taking some time, you can actually have the feel to also look at the DAX area to see how the processes are running at the end. So this is actually a new toolkit that has been developed, and we will be happy for all of us here who are actually interested in wetlands areas, or if you know any wetlands area, go and pick, you can use this particular to draw the polygon or select the area around it and generate the results. And to actually do, it's going to give you a map. It's actually going to be like this at the downstairs, then give you a general idea of it. At the end of this, you are going to have the open water, the wet, green vegetation, dry vegetation, and bare soil. So these are going to be the results of what you'll be having when you run the notebook. Actually, it will take some time to run, but it's still progressing at behind the scenes. So whilst it's still running, please, if you have any question you would like to ask while this thing is processing, you can ask the question. Maybe by the time we finish asking, by the time we have any question, we could have the system will already be done generating. So whilst we are waiting, please, any question for us?
Yes, I have a question.
Yes, please.
For the years, I saw that you chose 2019. So is there any range of the years that, because I saw that you have water observation from space, so does it start like in the 80s, like we normally know it starts from there?
Yeah, so you can actually specify because it's using the water observation from space and Landsat data, you can actually widen the range. It's not only for the ones I just used here. I use this one for demonstration purposes so that it will be able to load faster. So please, there is no fixed time
Okay,
range.
no, it's fine. So it's for the whole collection of the Landsat from the
Yes.
80s until now.
Yep. Yes, please. The only limitation within this one is the bounding box. If the bounding box is very big, the system will automatically tell you that the bounding box is actually out of range because of the memory size that has been allocated. So if you are using 16, the space that you'll be able to cover, 32 will cover a much more bigger area than the 16. So you can actually also use that also when you are running it for the area of interest.
Thank you, Ed. Hello, Edward.
Yeah, Joseph.
Yes, I was trying to say thank you for this nice tool. So it's really very interesting. So we are still looking for more questions. So otherwise, we can resume the session.
Okay. Okay, please, any other question in relation to the urbanization and the notebook?